Good day, everyone. Welcome to the Water Exchange podcast, which is hosted by Select Water Solutions. I'm Rick McCurdy. I'm Vice President of Innovation and Sustainability here at Select.
And I'm Nate Bonda. I'm VP of Technology here at Select.
We've dealt with produced water our whole career working in the oil and gas space, and obviously produced water has always been something we're interested in. How do we get rid of it? How do we best handle it? How do we do it environmentally? It seems here lately that we've gotten into a crescendo. It's reached a fever pitch to where there's a lot of interest in produced water in a lot of different areas.
We work in every major basin in the United States, and all those basins have very different needs, very different situations altogether. I think where you and I have been working the most recently, where the problem is arguably the most acute, would be in the Permian Basin. The volumes of water there are enormous, and the water quality as far as the dissolved solid content is also very high relative to many other places. So it poses a greater challenge. Right. Also, the area is quite large, so the logistics around moving that water around are complex and expensive.
Absolutely, and I couldn't agree with you more on that point. And that's something we'll kind of be touching on several times today as we talk about some of the innovative technology for potentially beneficial recovery of fresh water out of produced water. And that's that total dissolved solids, that TDS content you talk about. The salinity drives efficiency of return and what kind of technology we're going to look at. Mm-hmm. And you talk about the Permian, and we will probably have a strong Permian focus today since there is such an interest in the Permian Basin. But then you move to other areas like South Texas, for example. Don't have quite the volumes down there that we deal with in the Permian. Plus, it's a lower total dissolved solids. Typically, it's probably among that. It's roughly about 1/3 of what the Permian is. So it's a little bit easier to deal with, much like Colorado. Colorado's the same way. We're very active up in the DJ Basin there in Colorado, and that tends to be a lower TDS fluid as well.
Yeah, that makes the problem a little bit easier to solve when it comes to beneficial reuse, because removing the water from the salt, as they say, is a little bit easier to do when there's not as much salt.
Yep.
So, but I think that's once again one of the reasons why the industry has been focusing more on higher TDS regions where it's more complicated. It's more difficult to do. I know you mentioned the three basins that we kind of previously were talking about, but then also you've got some activity in the Marcellus as well, and you've got relatively high TDS water. Probably around 100,000 TDS on average, I'd guess.
It depends. So it's of course the Marcellus play is huge. If you're up in the northeastern Marcellus, in northeastern Pennsylvania, it's going to be up closer to the 240,000 range. Now you move to the southwestern side, the TDS gets a little better, but you get more volume.
Right.
Get less volume, higher TDS up in the northeastern part of the Commonwealth and higher. And then, of course, compounding that is the fact that the overall geology for disposal in the Commonwealth of Pennsylvania is terrible.
Yeah, it's not good.
So I lost count. Last count, there was like 9 active disposal wells within the Commonwealth. And so if you're an operator up in the northeastern Marcellus, generally you have 2 options. You try to find a way to reuse what produced water you have.
Truck it out of there.
Or you truck it all the way to Ohio for disposal. Right. Louisiana, to some degree, is very similar in some ways.
Yeah. Very few disposal wells.
Yep.
Your options are basically trucking it or treating it.
Absolutely. So we end up, and we participate in that. We see a lot of the produced water in Louisiana moved over to the eastern Texas side where the geology is better and it is more conducive to disposal.
Yeah.
So we've kind of covered on all those basins. Well, don't want to leave out the Powder River up in Wyoming, which Powder River is much like the DJ Basin. A lot of the same producing zones, low TDS, by and large.
Lower volumes.
Yeah. So much easier to deal with. So that kind of brings us to where we are today, or at least with produced water and what we're dealing with. So now let's tag on to that a little bit with some of the externalities that we know we're dealing with. Historically, disposal of produced water has been the simplest thing to do.
We are running up against the capacity of our existing SWD infrastructure. And I think the industry knows that everywhere, and they're interested in finding ways to dispose of less.
Yep.
Yeah, and I think that's going to be true. Obviously, it's a serious problem in the Permian Basin and probably where it's the most acute, like I said. But you're going to run into that as we develop out all the shale that's available for us to develop in many locations. And so I think the industry as a whole in all the different regions that we work has a keen interest in how this plays out. And I think the best place to, really put it to the fire and see if it's going to work is going to be in the Permian because it's hard to do there, right? But I think the lessons that we learn there and the solutions that we find will end up being applicable in many other locations, just because whether or not those locations are experiencing it today, as we continue to develop the resource, you're going to run into disposal issues. And some places already have disposal issues. I mean, like we said, Louisiana and Pennsylvania, you're not disposing anything there as it is. It's very costly. You're trucking it, hours. So I definitely think the interest is the problem is real and the interest is keen.
Yep. You're talking about these externalities, and that's what I've often said as a visual throughout my career when I'm talking about this potential option to beneficially recover fresh water. It's always been a cost issue. The cost of disposal was typically here, and the cost to treat and recover this water was somewhere way north of there. Right. And so what's happening now is with the externalities, we're seeing two things. We're seeing technology is bringing this cost down. Mm-hmm. We're seeing these externalities are driving this cost of disposal up. And as those two lines get closer and closer to converging, then this becomes a very realistic thing. Yeah. Now, it's happened before. It's up until recently, there was a facility up in northeastern PA that was treating that Marcellus brine, taking it all the way down to where they were recovering salt out of it. And
they're going into the Ohio River, correct?
Going into the Susquehanna.
That's in the Ohio Basin?
Yep. And so it could be done. It was expensive, but not as expensive as trucking water all the way to Ohio. Yeah. So it made sense for that to work. In the mid-2000s, there was an operator in the Barnett that in those days we believed the only water that we could use in completions had to be fresh. North Texas was in a severe drought, so there was not an abundance of groundwater available or surface water available. So they started using what's referred to as mechanical vapor recompression to treat their produced water to recover a distillate out of it that they could in turn use in ongoing completions.
Select was involved in that very early on. It was one of the first. Actually, that was the first beneficial reuse. We didn't call it that at the time, of course. Right. That's more of a newly coined term, but that was the first such project I was involved in.
We've kind of talked about all the externalities and some of the things we're dealing with. And I think what our audience would really like to start hearing about now is some of the technologies and some of the success we've had to date and how we participate in some of piloting this technology and doing all that. So why don't we start out with kind of a high-level overview of some of the stuff that we've looked at since we started down this path?
Well, since we've started down the path, we've looked at nearly everything. There's been a lot of effort and a lot of money and a lot of time put into this, and we've had a real commitment to it from a very early stage. So I believe I mentioned before, early 2000s, we were involved in some of the very first beneficial reuse. Like I said, they didn't call it that back then, but desal for more general term. And then recently, over the past 3 or 4 years, we've done several different pilots. And what we're going across in our R&D efforts, we're looking across all the different technologies. Yep. We are trying to remain technology agnostic and just find out what works and what doesn't, and what everything costs and what the challenges are, because there's going to be a different solution in different locations, right? Yep. You mentioned the DJ Basin. We had a great conversation about that. I learned some things because that's not not an area I've worked in as much. The DJ Basin has low TDS water, right? Yep. And they also have, in general, relatively cleaner water than other locations. As far as the species that are there, there's fewer of them and they're less problematic. So you are able to do different things as a solution in the DJ than you could even consider doing in the Permian, right?
Absolutely.
or in other locations. So we've had a very open mind, and we have tried to run pilots with everything that we can run pilots with, so that we are equipped with the knowledge and the skills and the operational know-how to be able to be effective and, you know, be there for our customers, be there for the industry when that call comes. So yeah, it's a big question to talk about the different technologies. I think we've looked at all of them. We've looked at traditional thermal. We've looked at we're running membrane distillation. We've actually run last year we ran a membrane distillation trial. We're running another one this year, and we've also looked at traditional reverse osmosis.
Yep.
And in some locations, reverse osmosis, which is a, you know, more of a commodity, currently employed large scale process, will be available to us to use, which is great. But when your total dissolved solids climb too high, it's no longer an option. So we need something. We need something else. So we're looking at many other things.
Yeah, and you make a valid point, because RO has been used in one form or another to treat a lot of different brackish water.
All over the world,
typically lower TDS, you know. Even seawater. Seawater, you see a lot of seawater RO desalinization plants. And the key to the reverse osmosis membranes are, particularly those seawater RO and traditional RO, is you've got an upper end limit somewhere between 50 and 70,000 milligrams per liter TDS.
And that's been inching up.
Yep.
The technology behind it, the membrane industry, has been gradually pushing the TDS higher and pushing the costs down.
Yep.
So when we first looked at this, you were maxed out on TDS for RO at 45 to 50,000.
Right.
And now there are companies in the market claiming a scotch over 70,000 capability for membranes that are not, you know, priced as if they're gold plated, right? It's an actual attainable thing, which is remarkable because it hasn't been that much time.
Well, and actually there is a process referred to in different ways. Some people call it cascade flow, some counterflow, cross-flow RO, and it's using ultra-high pressure membranes, and they tend to get up somewhere in the neighborhood. They can max out about 180,000 milligrams per liter, but it has to go through several different steps in order to do that.
And I would say in our looking into that, they are not as well proven or widely used as the traditional RO. The traditional RO, you've got, I mean, you and I could travel to, you know, several states in this country and dozens of countries around the world and see seawater RO, even high TDS seawater RO, because seawater doesn't have the same, you know, it doesn't have one TDS. If you're out in the Middle East and you're on the Persian Gulf or the Red Sea, especially the Red Sea, you have much higher TDS than the Atlantic Ocean or the Gulf Coast or the Pacific Ocean. So they're already deploying, you know, the original high TDS seawater RO systems have been out there for a while. So we can go out and see these things. They're done at scale. There's experts, there's vendors. Whereas we have explored some of the more exotic, I guess you would say, membrane solutions and osmotic solutions, but they are just that. They're currently more exotic, not as well understood or proven.
So, to case in point, because we talk about some of the TDS limitations, particularly of RO systems, but we couldn't do that in the Permian because the Permian TDS is way too high for those kind of deals. So we have to look at other options in the Permian, such as thermal processes.
Yeah, and we've our largest pilot project to date has been a thermal process in the Permian Basin, just north of Midland. It was a successful pilot. We're looking now at scaling that up. We had a very good and committed partner with an operator that worked with us hand in hand to get that done, and it's been a over 2.5 year process to get that done. But we're very excited about that. And the thermal processes, you know, they're not going to be a panacea. They're going to be applicable in some locations, and they're not going to be applicable in others. They are going to use more energy than RO, but they're going to be much more resilient and robust as far as their resistance to scaling and other things like that, and their ability to handle, theoretically, you can use thermal processes to extract water out of any level of TDS.
Absolutely,
Yeah.
absolutely. And one thing I think we want to really mention here, because a lot of times, particularly when I'm talking to academics about doing this and the option of doing this, one of the first things they always ask me is, what are we going to do with all the salt? Because in their mind, we're literally going to take all the water out and leave the salt and minerals behind.
I have had those conversations as well, Rick. And you recall early on in this, the industry marching through this, all this work, there were attempts to try to go to ZLD, zero
Yep.
liquid discharge. That is not really a feasible option.
No.
The scale of produced water in every basin, I would argue it's not a feasible option anywhere. At the scale that we produce these fluids, the amount of salt that would be remaining is unimaginable. It's enormous. You'd have literal mountains of salt left over. So our goal here is to extract as much useful resource as we can out of the produced water, provide that for beneficial reuse, and then to dispose of less.
I agree.
Yeah.
And that's been my philosophy all along, is all we want to do is pull a certain volume of a beneficial water out and concentrate up that brine.
That's right.
Continue to use your conventional Class 2 UIC wells for disposal of that waste. Because traditionally, that's what Class 2 wells are. Therefore, produced water is considered a waste. It's not considered a resource. We're currently looking at it about the potential to be a resource. And most recently in Texas, the Texas Supreme Court conferred that, yes, produced water is a waste product of the oil and gas production process, right? So we've dealt with that. So we're
A waste product with potential, Rick.
with potential. And you know very well, Nate, that I'm very passionate about membrane distillation. That's something I'm very passionate about. And we're in the process of doing some work in that area as well. Now, I've said it many times, membrane distillation is great. The reason I like it so well is because the membranes are more robust than we see with RO, so they don't foul as easy.
As easy, yeah.
You don't need the thermal energy that you need for the bigger thermal systems like we just piloted, but they have an Achilles heel. And Achilles heel is basically twofold. Hydrocarbons cannot touch the membrane. If they do, they're going to change the wettability. And you can't let a mineral scale build up.
I would add one more, surfactants.
Surfactants. We also know surfactants can be a problem because, again, with wettability issues,
right.
right?
Yes, sir.
If they hit it at a sufficient concentration. So I think you've came up with a unique plan to kind of investigate some of this stuff, and you want to talk a little bit about what we're going to do through our R&D function and to look at that.
So we actually just kicked that project off last week in earnest. We've been working on building the physical system for a few months. That's been fully incorporated and programmed and set up on our network so it can be remotely monitored. And we have moved the system into our chemistry department's headquarters on the west side of Houston.
Okay.
We have a full laboratory there, actually multiple laboratories. This is sitting in one of them. And we are going to work with our chemistry team, who has vast experience amongst the many of them, building chemical packages that will allow these membranes for membrane distillation to survive. So we will not see the scaling that has been one of the primary reasons you don't see them in wide scale use now. And so we have built a multi-path system. So it's not a system that was pulled from the market or that we're modifying. It is a from scratch system designed specifically to test chemical packages rapidly in parallel. So we'll be able to test, several chemical packages at the same time and do so iteratively and quickly without, having to bring in equipment, without having to spend significant time to swap the membranes, without even having to have a person there to operate it. And so that is, we're very excited about that. We're very excited about the potential of developing the chemical packages that will allow that to become a reality, because in addition to some of the benefits that you mentioned, I would state that its largest benefit is that it is a low temperature, low pressure process. And so many of the components, if not most of the components in a realized system, do not have to be made of metal. They can be made of polymers, which allows such a system to be much less capital intensive than a traditional thermal system. It is a thermal system.
Yep.
I think there's some confusion there a lot of times when I speak to folks. It is not membrane in the same sense as RO or cross-flow RO or any of that. It is a thermal system.
Yep.
It is a thermal system that uses a membrane, but it's a very different membrane.
Yep.
That membrane is relatively robust compared to osmotic membranes, but still is susceptible to scale. We think we can solve that scaling problem with the correct chemical packages. And once that is done, then we can build these things largely out of plastic, which is not prone to be corroded, would have a much longer life cycle than any of the steel piping, which in the thermal systems is going to require to be, more expensive alloy steel to be able to survive contact with heated produced water, which is a relatively aggressive substance if you're a piece of metal. So we're excited about it. It is certainly an R&D project. We don't have any assurances for the outcome.
Yep.
That's something that I'm very proud that Select is doing, that we're investing in something that we don't know the outcome 100%, but we know that the work is worth it, so we're doing it.
Absolutely. And I'm looking forward to it. And and I agree with you. I realize we don't have any formal plan set in stone yet, but once we do find these chemical packages that can potentially protect these membranes, I'm looking forward to us moving to a large-scale pilot with a membrane. Because as you mentioned, it is a thermal process. The great advantage of it is you don't have to get up to near boiling to get a raw. Generally, all you need is about a 50, 60 degree difference between the hot side and the cool side, and that's Fahrenheit, by the way, on this to get some sort of water vapor to transfer across and pick it up. So that's a benefit, which that also helps you stay away from some of the extremely expensive rare metals.
Your
like
high nickel alloys and very expensive alloys. I agree. There is great potential there, and I'm very glad we're exploring it.
So let's talk about, just briefly at a high level, let's talk about what goes into a pilot, because we talk a lot about we're doing some pilots, we're doing all this, and folks may get the ideas, wow, you just go out and set up a couple pieces of equipment and you run it for a month or two and everything's great and everything worked hunky-dory.
That is definitely not the case. Our larger pilots are multi-year projects. Mm-hmm. They are millions of dollars. They are thousands of hours of time. Yeah. So when we talk about setting up a pilot, you need partners. So we are a competent engineering and service company. We can help folks imagine these things more realistically, manifest those into physical things on the ground, but we really need to be working with operating partners that can bring in the water. First off, as Select is not a well operator, bring in the water, bring in some of their know-how, because I would say that our operating partners tend to have more of an academic presence within their companies than we do. We are much more focused on, making things actually happen, getting things done, turning the screws, building the things, operating the things, which we have great expertise at. The operators have less expertise there, but we need their academic, wherewithal. And that's been kind of the way that we have done it thus far. Is they've been providing tremendous support on the theoretical engineering side for some of these things, and then we have been providing the support for the practical applied engineering for this stuff.
I agree, and that's one of the things is that these pilots, people need to understand that the people that are going to come together to help organize and run the pilot need to be very nimble, very quick thinkers, because very seldom does you plan a pilot and it's going to go 1, 2, 3, then it goes 1, 2, 3.
That's right.
And when that doesn't happen, and you need to pivot and do something else, it can't be we're going to shut the pilot down and a week or 10 days from now we're going to decide what we're going to do. It's we need to decide on the spot Here are other options. Let's evaluate those quickly, see which one we like the best, and then move in that direction.
You got to roll with the punches.
Absolutely.
That is the name of the game for sure, Rick. It is it can be daunting sometimes, and it's honestly, with my team, it's something I wake up thinking about, which is how am I going to maintain everyone's motivation and maintain morale through some of these things, because I could tell you it is a fight for a lot of these systems. Like, you're starting off with essentially something, it's not essentially, it is a science project. It has not been built before in many cases. Yep. And you are going to learn a lot, and you're going to learn it the hard way.
Yep.
And you've got to have a team that is able to be flexible enough to do that and do it effectively. And I think that's one of the things that we bring to the table, and that my team brings to the table, is being able to do it the hard way and make things work and be successful doing it.
You talked about the quality operators that we're working with on some of these pilots. And I believe there's a lot of operators out there that have an interest, and they have a strong internal interest within their company at evaluating some of these technologies. How best would it be for them to approach Select to discuss these opportunities?
There's a number of ways you could approach us, and I'll get into that in a second. But I think I would say there's also a few things that should be considered, right? As I mentioned, these are large-scale commitments from both the technical partner, such as Select, as well as the operating partner. And so I think that operators need to understand that before they consider whether or not they want to get involved with one of these pilots, at that particular juncture. We would require a commitment of personnel, a commitment of a location. Yep. So that we would have, because we would need a physical place to set this thing, and you're going to need some personnel from the operator side, some of their high-level technical folks. So your physicists, your top-level engineers. Yep. We're going to require a long-term, major time commitment from some of those people. So I think the first question you would want to say is, you want to ask yourself, if you're an operator, is, do I have the location? Do I have the people? And then, do we have the time? Because realistically, for a large scale, you mentioned that 400 to 600 barrels a day, those are relatively large facilities. Yes, still. They are. And so even a time to build, you're talking about 12 months realistically. Yep. Maybe a little bit longer. You include engineering in that, you're probably closer to 24 months. Yep. To engineer, build, and realize the operation of something like this is a 24-month process.
A few minutes ago, you were talking about, particularly when we're partnering with operators and stuff like that, the personnel commitment, right? That we needed people available, people that were very experienced in dealing with these kind of projects that we could lean on when we needed decisions made and stuff like that. But at the end of the day, as we move to a commercial scale with a lot of this stuff, that's one of the things that we're probably going to really try to steer clear of, is a large personnel commitment to running them, because obviously that is a large cost aspect when you put a commitment back. So how do you think automation is going to play into this, to where we can operate these things efficiently and safely with less people on board?
It is going to be absolutely critical. We have incorporated automation into all of our operations for the exact same reasons. We've got to, it's not only cost, which it certainly is a big component of it, but it's also safety. Your exposure to a probability just increases the likelihood that something bad is going to happen, right? Yep. So we try as much as possible to allow our humans to not have to be on site next to risk. And so that's going to continue to be true with these facilities. It's been true with our disposal operations, our treatment operations, our transfer operations. It's going to be true with our desal operations. And we are already, I mentioned it earlier, we've already incorporated automation very heavily into these pilots. It would likely be uneconomical to do what we've done thus far without the significant amount of automation that we have developed and deployed into even these pilots.
Yep.
So we've run a few thermal pilots. The thermal pilots all have automated control valves, automated data capture, remote HMIs, so folks do not actually have to physically be there. That's especially critical for our operator partners because many of your high-level, your physicists, your high-level engineers, your PhDs, they travel around a lot within those companies to be on hand for multiple different issues and things that they're working on. We need to still allow them to be informed about what's going on with these projects that are very important strategically to their companies and very important to them because they're a big part of their work life. But we have, I have an example. We have the project we did in West Texas. One of our key engineering partners on the operator side, it was frequently working in the Middle East and in the Caribbean on offshore platforms. We needed him to still be involved. So we gave him remote access, secure remote access, which actually involved us supplying him with some equipment for his office and then giving him credentials that allow him to come in and observe. And that's critical. So even though it's a pilot, we still invest significantly in automation and controls for both safety and economics, like you mentioned.
And so with that, hand in hand with that, and we talk about the buzzword nowadays being artificial intelligence. Do you anticipate in the future that will somehow be involved, perhaps with hand in hand with machine learning, to help these facilities operate at their topmost efficiency?
I think so. So, AI is bandied around a lot, and it's sometimes confusing what that is actually practically does it mean. I think for what we do, something that I can see immediately where, what machine learning, that's 100% something that we'll be dealing with.
Absolutely.
You're talking, the amount of data that you're talking about from some of these is staggering. Yep. You've got hundreds of sensors, you've got hundreds of hours of runtime with hundreds of sensors, and you have many different setup variables, and you're trying to control for different variables and understand how tweaking, variable A affects variable B. Those patterns can be sometimes hard to suss out of very, very large data sets, and the machine learning algorithms that are available and relatively inexpensive nowadays and easy, there's a lot of folks with experience controlling them. Select has invested in a data science and data engineering team. Yep. That they're distributed across the country, and those folks use a lot of machine learning and AI to help us suss out that data and make it digestible. That's especially true when it comes to communicating a lot of complicated data to management stakeholders, because you need to make that digestible and understandable, and that's one of the things we call it our DEA department, our data engineering and analytics department. They have been instrumental in helping us kind of disseminate and digest that data.
We've kind of taken a look at all that, taken a look at what we're doing, and very proud of the work that we're doing in this area. Where do you think ultimately all this is headed?
I mean, that is the multi-billion-dollar question, isn't it, Rick?
Yep.
I think, but if I have to guess, if I have to, throw something out there, I would bet that we will see these systems. The first locations that you're going to see large-scale commercial desal systems are going to be, there's going to be a few critical places that have all the right ingredients.
Yep.
It's all about location. You're going to find a location that is just perfect for it, and it's begging for it. And if once you find that location, that one's kind of a slam dunk.
Yep.
And it's almost, you can almost look at it, I don't want to use this word, but you can almost look at it as a subsidized location, right? Because the location you may have an immediate use without any type of regulatory help. You'll have an immediate use. Yep. For the distillate. You'll have access to disposal. You'll have access to heat or energy of some kind that's available to you to use now, so you're not waiting years in many cases to get power to a location.
Yep.
And you're also going to have access to a network that can bring you large amounts of water reliably.
Absolutely.
Right? And I think, I guess I missed one. You also need to have access to pretreatment. Every single one of the technologies that we've looked at And everything that we've talked about today requires a significant pretreatment step before it can go to desal. And that is something else that Select has really invested in, is why we have over 20 permanent treatment facilities. And those treatment facilities are going to be a necessity. And whether that's with us or anyone else in the industry, you're going to have a treatment facility, you're going to have pipelines, you're going to have disposal, and you're going to have energy. And there's going to be a few spots where that just exists already. It's just there. And those are the low-hanging fruit. And I think you will start to see commercial units going into those locations within the next 24 months, realistically.
Yep.
And then whenever you get past that, doing that, we're all going to learn a lot. The industry is going to learn a whole bunch of what we don't know currently by doing that. And those are the places to learn, because they're going to be the lowest risk to your capital, because they have everything already there. Those you're going to need to find locations where all the components are there for their own causes and their own purposes, so that you're not having to invest capital to build all of those components just for the beneficial reuse. If it's all there already, then you can add beneficial reuse for, relative to the cost of everything I just mentioned, a relatively low cost. I mean, it's not going to be cheap.
Yep.
But relative to the pipelines, the treatment facility, the disposal, you've got lots of money in that. And so adding your beneficial reuse component will be relatively inexpensive, and it's just going to be the place where you do it. And we know, you and I are a part of conversations and aware of others where this is happening. Like these facilities are going to be going in. And I think we'll learn.
Yep.
And as we learn, we'll make those facilities more efficient, and we will make them less costly to build. And then that opens up the doors to place them in even more locations, right? Because as they become cheaper, and as they become cheaper to build on a capital basis, and then have a lower OpEx, then it just opens more doors. I would also say the industry, not just Select, is moving forward with developing more and more treatment facilities.
Yep.
And those treatment facilities are necessary to this. And the more of those that are around, the more likely it is that you're going to be able to successfully do desal, because those treatment facilities by themselves are expensive, complex, and large endeavors. So getting more of those built just opens up more doors. So I think you can see the light on this, right? Many people are building treatment facilities. Many people are building distribution pipelines, including Select. We're building hundreds of miles of produced water distribution pipelines. That is the necessary infrastructure to even really begin having a legitimate conversation about beneficial reuse at scale. And that infrastructure is going in today. So we're pushing towards the world where we will be able to successfully do these things, and I think it's going to be exciting. I think it'll be good for the oil field, and it'll be good for society in general. It will create a new source of water, which it just that doesn't happen very much.
Absolutely, and I agree with you completely that we're definitely moving in this direction. We've already talked about the fact that the states realize that they're going to have a lack of fresh water in the coming 50 years for their citizens. And that's we haven't even touched on new avenues where water could be used, such as in data centers.
Right.
That's the hot topic of the day, is we're talking about AI, we're talking about the data centers that are going to be needed to feed these AI monsters.
They need a lot of cooling.
And you got to cool them. You got to cool, if you put in a combined cycle natural gas power plant in order to feed electricity to the data center, it's got to have cooling.
It's gotta have cooling.
The data center itself's got to have cooling. And these are not small scale. These average size data centers are going to use somewhere in the neighborhood, or require somewhere in the neighborhood of 60 to 100,000 barrels of water a day for their cooling. Well, that's why typically you see the data centers we have now tend to be put in place in areas generally where they have access to a river, where they can pull water out of a river, large river, so they end up be up in the Northwest, even though we are seeing some. But there's a tremendous amount of interest right now in West Texas because natural gas is so cheap.
Electricity is cheap.
Electricity's cheap out there.
Yep.
And so that's the other big thing they need is lots of
land is
liquids.
relatively cheap out there.
That's right. But they don't have the water. They don't have the fresh water. Produced water could fit that need at scale, and produced water is going to be out there as long as we're producing oil and gas. They're going to have it available. So that could be a potential. So I agree with you completely. I think probably in the next 24 months, we're going to start to see some systems go in, at least what we would call a commercial scale. when we talk commercial, typically the pilots we've seen so far, and the pilot we ran are somewhere in the neighborhood of 400 to 600 barrels of distillate or permeate a day coming out. As we move to these commercial systems, I expect the larger ones at first are probably going to be somewhere in the 10 to 20,000 barrel a day permeate or distillate range coming out. And then ultimately what you will most likely see, if you want more volume than that, is you'll just see them kind of dominoed together.
Yeah, you'll see more locations. I don't think, and I think that depends, obviously, the size, the techno-economic analysis that's going to determine what a reasonable size is going to vary by region, right? In regions where it requires more energy, you're going to be energy constrained on how big you can make these things. And so at least in any one location. Across the entirety of the Permian Basin, there's a tremendous amount of energy available, but in any one location, you may not have, you're going to have a limit on how much energy you can practically bring to that spot.
Absolutely.
When you start talking about running RO, that's much less energy intensive, and we have precedent for massive RO systems all over the world. So you could start to make those as, that starts to get as big as you want to dream it, and as big as the water you have available, I think. But for thermal systems, I think you're right. You're going to be joining up smaller plants, basically. They're going to rely heavily on those pipeline networks. They're going to be distributed. Your water, even though we have a pipeline network, moving water across that pipeline is not free, right? It requires energy to move water across the pipeline. So you're not going to want to move water more than you need to. You're going to want to move it as few times and as short a distance as possible, and use the energy that you have available without having to make major capital investment into energy infrastructure. And so I think you're going to see, I agree with you, I think you're going to see that 10 to 20,000 maybe, and somewhere in that range. And then you're going to see those placed around these networks to take the best advantage of available energy and water infrastructure.
I agree. Let's talk about some of the regulatory challenges that are associated with produced water.
So the industry pressure to find other more useful and socially beneficial ways to deal with produced water has basically finally got to the legislative side of the world. And I think it's a good thing. It has really been surprisingly more of a conversation. I know you've dealt with the regulatory side a lot more than I have. In my previous career, I was a scientist, so I didn't really stay in the regulatory pool very much. I've been pleasantly surprised that how much of a conversation it's been. It's a conversation with the industry. I mean, I think I guess it's a good time to talk about the consortium here. And I think the whole concept of it is actually kind of neat. It's the concept of merging academia, business, and the state to have a conversation, to vet ideas, and see what's going to be, the best benefit to society, right?
Absolutely. And I'm glad you brought that up, because I want to point out the fact that industry has been actively looking at this and challenging ourselves over this topic for years now. I remember I mentioned North Texas earlier. So we had the Barnett Shale Water Management Council, which was operators in the Barnett focused on produced water and how best to handle completions and all that. After that, we had the Permian Basin Water Management Council, which has been an active function for about 14 years now. And that was also a group of operators and suppliers and midstreams working to figure out how best to use produced water predominantly to offset freshwater use. And they've done a phenomenal job. And then more recently, we've seen the states really start to take a look at their 50-year water plans and realize that ultimately they're not going to have the fresh water they need for their citizens based on their usage now and their expected growth and what they plan to do. So hand in hand with that, the states have started taking a look at this produced water, because there's very little instances of new water available out there.
It's unaccounted for water, and it's probably some of the only unaccounted for water that's going to be brought up to the surface. I mean, because I guess theoretically, there is the possibility of going in and bringing up brine or saline water independently, but those wells are deep, and that is very expensive, and so it's likely not a economically viable solution, right? But since the industry is already bringing it up, that is water coming to the surface incidentally that is unaccounted for water. It hasn't been claimed, which in this day and age, especially in the drier parts of this country, is very rare.
Yeah.
Yeah.
Absolutely. And so kudos to New Mexico. They were the first. In 2019, they decided to stand up and create the New Mexico Produced Water Resource Consortium, which it officially kicked off right at the start of 2020, just about a month before COVID hit. And then shortly thereafter, a year or two later, Texas stood up the Texas Produced Water Consortium, and now Colorado has stood up the Colorado Produced Water Consortium. And I'm very happy to say that I represent Select and serve on all three of those consortiums. I try to be a very active member. I try to help drive the conversation and get us in the direction. It's very beneficial to industry as a whole to be part of that conversation. Beneficial to us to take a look at different technologies that are being piloted.
I genuinely think it's sometimes hard to find examples like this in society, but I think it's beneficial to all the parties involved. The conversation needs to be had. I don't think you could get good regulatory action unilaterally. I think it would be blind to the realities of industry. And I don't think that the industry is going to be able to do. I just don't think we're equipped to the academic challenge of some of the research that's going to be necessary. And so the inclusion of the academic side of society is also really good.
Yep.
On some of the projects we've been working with various universities, and it's been very constructive. I've worked some with New Mexico. I've worked some in Texas. What's going on in Colorado?
So let me say this about the Colorado Consortium, and then this is the other two consortiums are just basically if you have a entity, whether it's a company or an environmental NGO or some other university or regulator, you just pay a fee and you get to be a member and participate. Colorado was a little different. Their legislature set it up as a set body that it was intentionally intended to be a group of stakeholders that would cover all the voices that should be at the table. So there's academics on that consortium. There's a certain number of seats for academics. There's a certain number of seats for state or federal regulators, certain number of seats for industry participants, certain number of seats for someone like me who's considered someone with experience and expertise in produced water. And so, but it's interesting. Been a part of that. It's been up and running for a little over about a year, going on a year and a half now. Interesting conversations. We've been able to, and not only did the state legislature set it up that way, but then they said, oh, by the way, here's 9 deliverables that you are due back to us by certain such date. Right. And each one had its own date. And I'm very proud to say that this group of folks have gotten together and met regularly on a basis, and we completed all those deliverables. Just turned in the 9th deliverable here a couple weeks ago to the legislature. So in Colorado, particularly in the DJ Basin. Now, Colorado's got several different producing basins, right? If you go over to the western side of the state, to the Piceance, they've been reusing produced water up there for a number of years because they had a lack of water, and it was also difficult to find disposal and move it in that area.
There's not a lot of infrastructure in that area.
No.
Yeah.
No. Now, you come into the DJ Basin, very little reuse.
Yeah.
Because again, it's some of the regulations dealing with how you can store water and how you can move water and do all that. But the state's really interested in looking at how and reducing freshwater use in the DJ Basin. So that's kind of what this Colorado Consortium is really focused on now, is how do we help?
I would think that in Colorado, the DJ is definitely the big prize.
Absolutely.
Like, you've got the infrastructure, you've got the most activity.
Yep.
Yeah. So you can have the largest volumes of water. It's also, as far as beneficial reuse, it's also closest to the potential reusers, right? Your population center there on the Front Range is closer to the DJ than pretty much anywhere else. And as far as hydraulically, it definitely is, because you're not having to go up and over or down large mountain passes to get to them.
Absolutely.
Yeah.
So one of the things that the consortium has done so far is they've been able to get everybody to come to agreement on having targeted goals for reuse increase up in the DJ Basin over the next decade or so. Industry has agreed to meet those targets or go after those targets, which will help offset freshwater use. So where in West Texas, New Mexico, we do a tremendous amount of reuse and offset a tremendous amount of freshwater. That is the goal now, to move into Colorado and kind of do that.
What are the things that you see that are challenges with the states that are currently considering or allowing beneficial reuse? So you mentioned Texas, New Mexico, and Colorado, and I know that you've got the consortiums there, you've got legislation there. What are the challenges? What are some of the things that you think they may have missed or that are going to pose a challenge for entities trying to actually make these projects real?
Obviously, in Texas, we've seen some tremendous steps forward through probably beginning in the 2013, 2015 legislative cycle, moving with helping to recycle produced water and reuse it. And so the regulatory body in Texas, Texas Railroad Commission, they started adopting rules to help with larger storage and larger movement of water, which allowed us to significantly offset freshwater usage, particularly on hydraulic fracturing completions.
And right now, I guess you're speaking about the more traditional and entrenched reuse for oil field exclusively.
Exclusively for oil field.
So you're talking about cleaning up our brines.
That's right. Cleaning up our produced water, as you mentioned, in our treatment centers,
That's right.
to where now we can get it of a quality. It can be reused in a completion and used in place of fresh water if necessary.
Yes, sir.
And we've done that. We do that a lot of times. We provide 100% produced water.
That's right.
For frac. New Mexico has moved heavily in that direction as well through their Produced Water Act that came into place here a few years back, and not only encouraged but potentially penalized using fresh water in completion. So it really encouraged industry to try to use produced water as much. So we also see a lot of treatment of produced water up there for reuse in completions. Now, when we go to Colorado, I mentioned earlier that on the western slope, the Piceance Basin, we've seen reuse up there for decades now, but there's also not a lot of disposal infrastructure in place. We move into the DJ Basin, and we haven't seen a tremendous amount of produced water reuse because, as you mentioned, we have a much denser population over in that area. And because of that, the state has taken efforts to
More cautious approach.
Right? So open air impoundments for storage of a treated produced water are not allowed in the DJ. Well, the problem there is when you've got a completion that's taking on average 70,000 to 80,000 barrels of water a day, if you want to make a significant dent into how much of that is fresh water, then you need those large storage impoundments where you can feed that water to them.
As I mentioned before, these systems function successfully through a combination of large-scale treatment facilities, pipelines, and a part of that is storage. You've got to have large-scale storage because the supply and the demand very seldom link up in time exactly. And then there's also a time delay from the time that the water is produced. It has to be transmitted from wherever it was produced to a location for it to be treated, and then from the location for it, the treatment location, it needs to be then transmitted to its reuse location, and that is whether or not we're talking about desal or just reuse of treated produced brine. And I think that will be a difficulty in Colorado because, as I mentioned, the pathway to getting to beneficial reuse includes storage, pipelines, and large-scale treatment. And so if you're going to have rules that make it more difficult to have those things, it is going to be much more difficult to realize any kind of large-scale beneficial reuse.
I agree. You know, if we use just an example, say we've got a facility up there and now that's treating produced water. Well, that facility takes in about 10,000 barrels of water a day and cleans it up. Mm-hmm. In a perfect ideal world, if we were using 100% of that water for our completion, an average completion, we could offset about 1/8 of the current water usage on a day-to-day basis because that's all we treat. We treat 10,000, we can send out 10,000. But if you want us to be able to treat...
I think we just upgraded that facility to 15,000.
There you go. Well, if you want to treat 20, 30, 40, 50%, offset 50% of the freshwater use, that's why we have to have those large storage impoundments.
It's going to be necessary. The timing of all the different components is just rarely going to match up perfectly so that it could flow through in one pass. You're going to have multiple steps. You're going to have to store between those steps, and you're going to have to store for the demand afterwards for for the products that you create, for sure.
Thanks, everyone, for joining us today at the Water Exchange Podcast for this in-depth dive into produced water and the potential future that it holds for us. Feel free to go to our website at selectwater.com and check out other podcasts that are available there as well. Thank you.